Thank you. All right. So now that, my friends, is too funny. I just opened the wrong. Sorry. Give me one more second here. I just closed my screen here. I do apologize. Give me 1 minute here. We're going to be covering today the introduction to computers themselves. In this quote, this one here, we are during this session. Overall, we're going to be learning the basic principles behind how a computer works. You're going to learn to discuss the computers using technical vocabulary terms and learn necessary safety precautions that you should be taking when working with an actual computer itself. Our main objectives that we're going to be learning here is to be able to describe how computers work, including the relationship between the hardware itself and the software, be that it is an application or if it is the operating system itself. Explain the key safety precautions to take and the tools to use to protect yourself. We need to understand and be able to describe how computers works, including the relationship overall with its software, because of the fact that a computer is an electronic device that's storing and processing data according to the instructions that the actual program is giving it. One of the things that we're going to also be learning today is the language that the computers speak in, which is in ones and zeros or binary. Need to understand the base 2 math that's implicated with this. Also understand that there is a way to actually change these ones and zeros to actual characters, which is called ASCII. And there is analog versus digital signals, depending that is what we will be able to decipher. Another area that we will be is understanding how information moves throughout the bus system itself and the serial interfaces or parallel devices. We're going to be able to define a physical component, which is a hardware, and is basically physical. It could be either a hard drive, a monitor, a keyboard, any of that stuff. You can also be speaking in reference to your BIOS and how it helps in the startup instructions of the motherboard itself and managing the actual devices that are installed. We're also going to be covering the broad understanding of an operating systems, what the main functions it is, how it serves and interacts with the actual hardware and the users when they're actually using it. Understand and be able to decipher uh, how applications and or programs run on top of an operating system. Also, we're going to be able to review what are inputs and how is used by the actual user. That would we covering, like keyboards and different other things that are inputs. We're also going to be covering what are outputs, like your monitor or printers. The other area that we will be including is, like I said earlier, we're going to be explaining to you the key safety precautions to take, the tools necessary to be able to protect you and the computer itself. It is important to know the basis of how electricity works, to understand the safety precautions, recognize the safety and protection rules, including never, ever, 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 ever to connect to a chassis that is still powered. That depends. If you want to be able to fly, that is one good quick way to learn how to fly. Not sure how it's going to work out by the end of it, but you will learn how to fly. Power supplies, printers, and CRT monitors are actually replaced by special technicians. We wouldn't ever open up an actual power supply, and we'll get into that detail itself. Fires, we're going to be reviewing the different types of fires and the way they should be extinguished. We'll also be covering ESD, electric static discharge, and how it affects any of the components and what type of damage that we can obviously avoid if we fail to adhere to any of these things. Questions so far? And that was just opening up the book. In reference to it itself, our key things that we will be reviewing is adaptability, to be able to adapt, and obviously growth mindset. Questions, concerns. All righty then. So let's see who we have here as our guinea pigs. We'll start with Shiloh. Shiloh, help me out here, bro. Can you read for me the definition of a computer?
The definition of a computer: electronic device for storing and processing data according to instructions given to it in a variable program. Variable.
Variable program. Thank you. That is correct. So if we see here, can somebody name something that's not on the screen to me that it contains a computer that you usually use throughout the day, or even not even throughout the day? Maybe you know that it does exist somewhere else.
PlayStation.
There we go. A console. Everybody got that one real quick. Anything
Your
else?
phone? Your phone?
Well, your phone's here. Don't give me something
Computer
on the
inside your car.
There we go. I like that one. That's the one I love to hear. Believe it or not, your airplanes, computers, all that stuff. Sorry, your airplanes, your cars, anything nowadays has a small computer. The worst thing about that is if it fails, basically you can't even accelerate. No longer is there a stick that's actually pulling the accelerator with the gas. It is a computer that senses you pushed a button, like in a video game, and basically that represents zeros and ones going back and forth, and voila, you got more gas going into the engine. And I'm not a gas guy or a car guy, so can't tell you combustion, but you get the point. Overall, it's everywhere. And the worst thing about this is that if this little component fails, you are basically dead in the water. I've seen people where the computer just fails on a car, it won't turn on or it starts going, but it's really not the engine that's giving the problem. It's actually the computer. The computer failed to be able to mix the amount of oxygen and gasoline going through all that intricacies that's necessary as a regular car used to do. And now that computer is doing the job of all those different components. We have to be fully aware that this is not the only thing that we can actually fix. We need to be broad in our expectations that if you thought this was the only type of computer you can fix, think again. There's plenty of different types of components. And what types are there? Let's see here. Help me out there. Nicole, can you read me supercomputer, please? Just a definition of supercomputer.
The fastest, too big for personal use, as requires a facility to house, mainly used by the science community. Example, car manufacturing.
Thank you. Kevin, mainframe.
Lots of storage space, lots of input, output devices that can connect across vast distances. Example, servers.
Thank you. Joshua, mini computer.
Faster than a microcomputer, holds more storage, and has access to more input-output devices. Example, point-of-sale machines, all connecting to one central computer.
Thank you. Afrilis, microcomputer, please. You're on mute, or it's your mic itself, not the program.
Wait, me?
Afrilis.
Oh,
No, I meant the mic on his thing. Not Michael. You're still muted. I guess Michael, I'm really sorry. Something's wrong with your headset. Yeah.
all right. Microcomputer called micro because of the chip being small and affordable. First made by IBM and first to combine productivity with games. Example, personal computer.
Thank you. Yeah, as we see here, we have a plethora of different sizes. A supercomputer, everybody probably familiar with those in those car manufacturing plants where it automatically puts Humpty Dumpty back together again. No longer is it being done by people in that assembly line. This huge computer that's as big as a house basically does all of the functions, and everybody that used to work in there is no longer working there. But that's a
You're
mainframe
missing one.
itself.
Oh, sorry. You're missing a quantum computer.
I
Isn't
would
that a
have to
computer?
agree. Yes, that is a type of computer, but it's not the type of computers that we will be covering A plus. But thanks for bringing that one up. That is correct. In reference to the ones that they will be covering, though, will be these here, which is the four that we see. Mainly, those are the ones that they want you to be able to review. Mainframe is all the servers. Basically, usually you'll see that as a email server, any of those things, maybe an actual AD server for Active Directory. You have your mini computers themselves, which you've seen a lot out there, especially in the POSs in the middle of the mall. You might see that, or even in a doctor's office nowadays, they have that little POS device to allow you. And Publix, Home Depot, they all have these computers in there now where you yourself are checking yourself out. That is a mini computer. The microcomputer, because obviously of the size, IBM did create the first personal computer, believe it or not, that I'm aware of. And it is the size is the reason why they call it micro. Any questions on these four different sizes? Yoki dokie. All right. Now we're going to get into the nitty gritty of it. Inside here, we're talking about the different things here. If somebody can give me an example of a hardware, which is a physical part of a computer, besides the examples that we have here, if somebody can give me an example of what they can understand is a hardware.
The graphics card?
Physically, I can touch it. Yes, that would be one. About firmware, anybody can give me a idea what they believe this hardware chip with software stored on it. What is this firmware?
An SD card.
I'm sorry?
An SD card.
Mm, that would be more of a memory card, but close. It is a type of memory.
GPU? No.
I'm sorry.
GPU?
GPU is very, very close to being a CPU. Various is it just a graphical power processing unit versus a computer processing unit, but it is a CPU that's mounted on the graphic card itself. But I'll stop torturing you. It is a chip that is stored. It's a type of ROM chip, a read-only memory chip that stores basically the configurations or the ability of recognizing any different type of hardware, be that it is a memory card, it's a hard drive that you put in there, a video card. All this is stored in that little chip. The actual little ROM chip itself looks like a little spider. So I'll show you what a BIOS chip looks like. So this little guy here, come back. Am I sharing the right? Hopefully you guys can see this. You can see the guy? No? Yes?
Yes.
Okie dokie. Thank you.
Yes.
So this guy right here, he's got everything stored, everything that you can consider as a motherboard or as a main board, whatever has a board itself has a BIOS chip that is basically where it is able to translate all zeros and ones into some sort of language that each component can understand. Every single component that's in your computer has a different language. They all say zero or one, but the way that they're able to translate or decode it, the motherboard with the firmware has that translator for it. So everybody's saying zeros and ones. So if I say 000 111 and I'm a keyboard, that means something different than if I am maybe Excel, as an example. It means completely a different thing. Next is your software. Can somebody give me an example of software?
Zoom.
Excel,
There we go.
Excel.
MSI Afterburner.
Zoom.
Yeah. Zoom.
Mac
There you
OS.
go. Mac OS. That is correct. Now, the variance between those two different software is the operating system itself is the go between the actual hardware and the software. So all of your applications get stored on top of your shell, which is the operating system, which you can say it's shell. Just like an eggshell, it's on the outside. You could always think about it that way. The shell is the physical representation for your eyes to see and to be able to talk to the actual kernel. The kernel is inside the shell, just like a kernel in corn or in a nut. It's inside. Therefore, that's the guy, which is still part of the operating system. We'll get into the details of that in a later chapter, but so we can talk about it right now. He then talks to the actual physical hardware. Therefore, the actual programs get stored on top of the shell of the operating system, speak to it, and then the operating system, who has full control of the hardware, then sends the ones and zeros to represent what it needs, be to the video card, be to the hard drive, wherever it needs to go. Any questions on these three major components?
No.
Can you go a little bit more into firmware, the difference between a little bit?
Yes, sure. Firmware is a physical chip which they store a software on it. This firmware, you've seen it always. When your computer turns on, a lot of you see a Mary Grand or a Maris, I don't know, remember his name, his perfect name, and it shows you like a little black screen. And if you hit delete, you can go into this little weird screen and it looks beautiful. Anybody ever seen that guy? Usually it's counting your memory when you turn it on before the Windows logo comes out. Nobody? Anybody?
I have.
So that's what the firmware it does. It has a BIOS uh, um, installed in there for the computer itself. This BIOS chip, which is the basic input output system, that's what BIOS stands for, basic input output system chip, stores everything necessary to allow any hardware talk to an operating system. The operating system talks to it and says, all right, here you go, and gets everything going around through it. But without the BIOS, you would never be able to recognize a video card, to recognize the memory, to recognize the motherboard itself. It won't recognize anything. It also stores the clock, time. You might have seen it
I had
when
a,
your battery, that little clock battery runs out, and you see that you got no time. It says to reset your time.
I had a question. So,
Hmm.
like, would firmware be like the when it says like i5 core processor or like the M1 chip that Apple came out with not so long ago? Like, is that like considered firmware or is that considered hardware?
The M1 chip is a chip. It's not the BIOS itself.
Okay.
The BIOS is like I'm telling you, it's a set of instructions that is saved in there so that it can actually check your computer, check and see what's on there. I can't explain any other way except for that way. Maybe a TA may have a better way of explaining it, but it is a physical hardware which you cannot change unless if you have a special other software to boot up with. Usually the BIOS, unless it's if an electronic firmware, will not allow you to even upgrade or do anything to it.
I
It
think I
is
got
hard
away,
coded in there.
Diego,
Hmm.
Arturo, and everyone else. It's instructions that is in place that doesn't change often unless, like Diego said, it you have some special tools to change it. But before your computer turns on fully, there's checks and balances that it has to go through, and all that information is stored on a chip inside the computer, the away from the CPU and all of that. It's a physical hard chip that's in there with software embedded for that. And if you notice on a lot of different devices, you always hear about firmware and a version. So your computer comes to you with a certain firmware version that can be updated if necessary, but out the box before your computer takes off, it's checking those checks and balances through that physical chip that's embedded. And when we actually see inside the computer, we'll show you where it's located as well. And I think that will help us also.
Hmm.
I can
Okay,
also.
sorry, I have a question.
Yes.
Is firmware just the chip itself, or is it together with the program that is written in it? Because
That
it's
is a
like,
good question. Yes, firmware is both a chip and its BIOS, the basic input operating system, is installed on top of this chip. All encompassed together is the firmware. You can see now a screenshot of an actual BIOS. When you go into it, it allows you to configure the actual CPU, the IDEs, or your hard drive ports. You're able to change your actual power consumption, all of this before it actually boots. This CMOS itself stores it on a separate chip. You have the program that you see here, which is the blue stuff, and then everything that gets configured goes to the CMOS chip to be stored. CMOS saves all the configurations because you could just imagine how crazy it would be that every single time your computer turns on, it's got to figure out what CPU it is, how much memory, what type of hard drive, what's the video card. That can get very annoying, right? And it's going to take time for it to do it. So what it does is saves it there and has the information when you turn it on. Firmware in there, that actual BIOS chip has what they call a post. That post then checks the list of all those components to see if there's a problem or if something's missing. All of that is encompassed inside that firmware. Without the firmware to be able to translate ones and zeros back and forth, your video card is useless. Your hard drive, you won't be able to use it. It used to be that you actually had to go manually into the BIOS and set up everything in there. You had to set up your COM ports. You had to say what type of hard drive, how many heads, sectors, cylinders your hard drive had. All of that had to be, even your LPT ports, everything had to be configured manually in here by a technician. That is all now gone after what they call the uh, plug and pray or auto sense, and it obviously then senses it itself. It's able to instruct everything and then take out the book of translator for every single device. He's got every single book reference to make sure he knows how to talk to a video card, how he talks to the hard drive, how he talks to memory. All of that is stored on that chip.
I have a way to maybe make it easy for people to categorize hardware, firmware, and software. Think of it like this: hardware, for you to modify hardware, you're most likely going to break it. Firmware is going to be a very specialized embedded software, which is very difficult to modify. If you make a mistake, you may as well just lost the system itself. And software is more malleable. Think of it like that. Some of it.
Hello?
You muted yourself, Lazarus.
Hello? Hello?
Oh, is it working? Did I lose you
There
guys?
you go.
You're good now.
You were at some of
All right.
it. Some of it.
Said malleable, and then after that, you muted yourself.
So basically, I just want you guys to have a mindset of hardware is that if you were to modify it, you're going to need a hammer. Think of it like that. You're going to break it. To modify a CPU, you're going to have to go physically to the CPU. Not going to work out. Firmware. Technically speaking, there is software, but it's a specialized embedded software in the memory known as RAM. Sorry, not RAM. ROM. ROM. Read-only memory that Diego was talking about. A lot of motherboards have that saves data. All of the information's there. If you mess that up, you might as well mess up the whole computer. And then software is what we're talking about now, but the software we're referring to is easier to modify.
Okay. Any other question on firmware? So firmware encompasses both hardware and software. It is a chip that is mounted onto the motherboard itself or the actual circuit board, depending if it's not a motherboard itself. It could be a riser card, which has firmware, or some other circuit boards, depending on printers also have a main board instead of a motherboard, but all of them have a BIOS chip. It's a hardware chip which has software stored on it. That's what gets confusing there. It has both hardware and software. Okay, cool. So we'll see here the different various hardware. We have our motherboard here, our network card, power supplies, actual chassis. Anybody recognize this blue one? Am I not sharing my desktop again?
It's a GPU, I think. No, looks like
Graphics
it.
card.
Yeah, it's a graphics
Yes.
card. Yes.
The black guy back there though, on the blue thing, that's the guy you're looking for. That's the GPU. That's the graphic processor unit, the one with the fan. But
Yeah,
the actual thing here, that is a graphics card. Anybody recognize this guy, the big guy here? You're using him now. Give you that much of a hint.
it's the
The
chip
mic
that
and audio
The
input.
USB, the
yeah,
USB,
Uh,
the
like for internet.
Somebody in the middle. There we go, Mike. Somebody
Yeah.
said Mike. This is a NIC card for your internet network interface card, which nowadays is usually an Ethernet card. Here's your actual sound card. It looks like it has inputs, outputs, and maybe even an antenna, if I'm correct with that little thing back there. Anybody recognize this guy down here? The bottom left-hand corner?
That's a hard drive.
That is correct. That's the old HDDs, not the solid state drives nowadays, but that is a hard drive. So main thing that we need to understand is that any computing hardware can be a component, a connector, a slot, a port, a peripheral, anything you see here. So as long as you can physically touch it, it is hardware. Physically touch it. I can touch it. That means it's hard to me. Software is in the virtual world. I can't touch it. I can't see it. I know it's there, but there's no way I can prove it's there. With my own eyes, I only have to take it for your word that Windows has a whole bunch of stuff in there. Can I actually touch Windows? Can I feel Windows? Anyone? Can I touch
No.
Windows? Can I feel Windows? Can I touch Nearpod? Can I feel Nearpod? No, but I can touch the monitor, right? That's hardware. What's inside in that virtual world of ones and zeros inside this monitor, that's software that's messing with you. Be the mouse moving around, the colors on the screen, that's all software messing with you in the background, being represented on the hardware, which is the screen. Next, firmware. A little bit more deep dive into it. It's a, as we said, a software stored on this little spider guy or ant or whatever you want to call him, centipede. Has obviously a startup instructions for the low level hardware. One thing that you'll notice is that usually these video card or the colors that you're seeing are usually under 256 colors. It'll give you VGA resolution, but it's not going to go into the high def resolution. Same thing with anything else. It has all of the basic instructions to be able to talk to it to the actual motherboard and to do whatever it needs to do. And like we said earlier, it does require some special utility to be able to change it. Usually it is not changeable. They might even just send you the actual chip itself for you to take it out with a special tool, which is a little guy that has two teeth. You pull them out and you put in the new ROM chip. Any questions on firmware? So he's in the middle and stored on the motherboard itself. Software. All right. So as we said earlier, software can be an operating system itself or an application or program that runs on the operating system itself. The operating system is a interface to be able to control the actual hardware. As we see here, I'm going and moving my mouse around, and you'll notice then it also represents it on the actual screen. So you could be able to see that while I'm moving this little ball around in the mouse is getting reflected onto the screen itself. It manages communication from the software back to the hardware, back and forth, so it could be able to do what it needs. As I stated before, it does run any application on top of it. And that is why a lot of times when you purchase an application, they tell you specifically what operating system that it can run on. Without that operating system that it being able to run on, then it will not work. For instance, if I have an actual application that can only run on an iOS device, trying to install it here on Apple will not work. I'm sorry, on Windows, it will not work. Any questions or doubts on what an operating system is?
You lost your background.
Thank you. Yep. Go back over here.
I like the curtains though.
I love the curtains.
Soft light.
Not sure why he likes doing that to me. Does it whenever he wants. I guess he just wants me to go to the beach. Oh yeah, life's in the beach.
You're back now.
Woo! Next, here we said applications themselves. The applications themselves perform all human tasks. As we see here that if I want to open up Excel and start calculating things or even writing something inside my notebook, all of this is capable because it runs on top of the actual operating system, which is it's specifically written for, as I stated before. Each one, even your Internet Explorer or even your little Google Chrome has its own little type of installation for the operating system itself. It will not work specifically if you install on top of Windows a Mac OS version of Google Chrome. Any questions or doubts on software, be that it's an operating system or an application? Okay, so now we're getting into the nitty gritty to the point that everybody just starts scratching their heads. This is the part where we learn how a computer actually talks. Be whatever it is, doesn't matter where you go inside this computer. This is the hard part. It doesn't speak English, doesn't speak Japanese, can't speak even Mandarin. What it can speak is a simple thing called on or off, ones or zeros. Computer is only able to communicate by binary. Everything else is just a human representation of what we want. It's got no clue that this screen right here says language of computers and everything that you see here. No clue. But it does know that it needs to have every little single dot here with ones and zeros, letting it know that every single bit in this screen needs to be either turned on or off, and it has 3 extra ones for its red, green, and blues to be able to shade this for you. Without that information, you would not see this. Likewise with text itself, it's able to change what we consider bit. Bit is the smallest form. That is what we said. It's either on or off. That is the smallest piece of information inside a computer. If you have 8 of them together, which is usually how they send things, which is a byte. If you have 8 bits, it's considered a whole byte. If you actually just take a small piece of that bite of the pie, you're actually only nibbling. Don't ask me. It's called a nibble. It's 4 bits. It's their little joke. Now, what gets more confusing after that is kilobytes. Kilobytes, which is 1,024 of these bytes. Megabytes is the next level, is basically 1,024 kilobytes, and gigabytes is 1,024 megabytes. But then you may say, Diego, how in the world did they get those numbers? What kind of math do they have? As I said earlier, this is a base 10 technology, sorry, base 2 technology, not base 10. Everyone here is used to base 10, which is zeros through ones. Therefore, to be able to, for ASCII, they need to be able to translate what we consider the base 2 into a number, a mathematical number, to be able to be represented to a character on your screen. How can they do this? With the actual base 2, you'll see here that if I go and put 2 to the 0, this is equal to 1. If I say it is 2 to the, maybe I can do this. Hopefully that's, of course not. I forgot to hit equal. 2 to the blankety, boom. That is equal to 2. 2 to the thing is 4. 2 to the 3, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192. You must, believe it or not, be able to do what I just did. That's how you get to
Nice.
1024. If you can do those things in your head, you'll be able to do this little mathematical thing. And that is the game you need to play with your head. Repetition, as we said, is the mother lode of learning. Without that, my friend, you will be completely lost and not be able to understand one word that's coming out of that computer's mouth. As I stated a moment ago, ASCII is a translation from that. So computers could only understand, as we said, numbers, but to be able to route the letter A or the at sign, it is as simple as a little table that's called ASCII table. Now, do not think that you need to know this. Don't even just turn off Zoom and jump out of here like you got to know this because that would be mean. The computer's got to know it. You just got to understand, especially those that deal with programming or will be dealing with programming. You best bet you need to know this one. If you're in programming, you've got to know this. Believe it or not. It's something that you can still look up in Google. It's still something that you can still look up anywhere you want, but you have to understand where to reference this. So if I have straight zeros and I'm writing text, it is null. There's nothing. If I have an equivalent to 32 in decimal, which is hexadecimal is written 20, which is equivalent to 000. I'll bring this guy back over here. Be much easier. It's equivalent to just turning this guy on only. So I'll have 000000001 0, and then another 0 0 0 0 0 0 0. So that's 2 bytes right there. No, lie. Sorry. That's 2 nibbles, 1 byte. The 20 represents 2 nibbles, 1 byte. 32 represents a whole byte. Questions on what an ASCII table is and or how a computer is able to represent zeros and ones into letters.
Can you explain it a little bit more? I'm still a little confused on it.
Okay. Do you
I have a
understand
question.
that it could only turn off and on information based on bits?
That part I understand a little bit, just the part
Okay.
where you're just reading the chart, like
Okay.
trying
Not
to
a
read the
problem.
chart.
So let's say I have 32, right? We said earlier. So what the computer is going to do to send 32 across through the motherboard, it's going to send 0 0 1 0 0 0 0 0. When your text, be Word, be your Internet Explorer, or whoever it is receives that code, it translates 32 to space.
Ah, okay. So the decimal on the left is what it's kind of like
That is
so
the equivalent to 10, base 10, the number representing base 10 in a human
ah
in a human language what we're used to. We only know what is decimal or base 10. This is for us. The blue is our representation and what we understand as a number. It only sees zeros and ones. The red is the translation from decimal to hexadecimal. If you've never done hexadecimal, unfortunately, you're going to have to learn that one. And we have a little game to learn that a little bit easier. But it is easy. Hexadecimal, believe it or not, is much easier to translate from binary to hexadecimal than from binary to decimal. It's much easier after you get used to
mhm.
it. But it is easy. Any other question from what this chart represents? So we'll look here. If I have 128, which would be all, sorry, 100. Let's go for Z. The letter Z would be equivalent to 90. So if I want to make 90, it's as simple as one of the easiest way to figure that out is I turn on the closest one to it. So this guy is 64 already, right? But if I turn on 64 and 32, then I'm at 96, so that doesn't work. So I gotta know that it's gotta be this guy here. It gets a little difficult for us humans, but believe it or not, the computer is able to do this with ease. That, my friend, right there is 80 plus my other 10 that I'm missing. I'm not gonna go through the whole thing. I already know what the answer is this. And this is what it sends. He only sends this across.
This is a good thing to remember if you're going into Network Plus. They don't necessarily get into this for A plus. It's more theoretical, but definitely for Network Plus, this is something you would need to know.
But you have to understand it at least. Minimum is understand that it does not speak to anywhere at all does it speak in text or any other format than except for on or off. That's all that goes across to the actual hardware. Your shell, which is your operating system, translates all text, all of the all of the stuff that you see as a human into the kernel. The kernel then changes it into machine language, which is your zeros and ones.
I have a question.
Go ahead.
Why is there only 7 on this chart that you've made? 7, it only
This is
goes
a
up this.
byte. This is a byte, and there's 8. This is
Got
one
it.
byte, and you didn't notice one thing. It actually has 8.
You're
Does
right.
not have
You're right.
7.
Because of the 0, that's what I missed.
That is correct.
Okay,
Thank
I
you.
also have a question about where hexadecimals actually are used, because it's like, okay, it's obvious that computers speak
We
in 1 and 0, but why
hexadecimal we will
hexadecimal?
see in MAC addresses. We're going to also see in IP version 6. So they will be using hexadecimal during those times that you're actually being able to translate. So it's more of being able to translate back and forth. And I don't even think they're going to test you that I'm aware of on A plus on that. It's just the knowledge and understanding on how it gets done. So I've
Well,
yet to see a question of hexadecimal to change.
they will, you won't have to do any hexadecimal conversions, but they will ask you to identify specific types of hexadecimal IP addresses.
Yes, that
And
they will.
understand a basic understanding of what hexadecimals are as well.
And we will get into, right now we're just going real high level, just a small little introduction, but when we want to talk about binary and hexadecimal, we will do a deep dive into that. All of this right now is just a very high level skim over the subject.
Thank you.
Not a problem. Thank you. Woohoo! Among Us again. Oh no, wrong day. All right. Next area. No questions, doubts. So remember, we do not have to have this memorized. If you memorize it, I will kill you. No, I'm just kidding.
There's a certain pattern to that, though.
Oh yeah, there is. There is. The
After
easiest
every
thing that
9,
you can notice is where A is. That's the most important one to remember, which they will do for coding, not here. So you need to know 65 and you need to know, I think it's 91 or 97. Sorry, 97. 65 and 97 would be coding because you use that for variables.
yeah,
But
and then
that's,
after,
like I said, it's not here. They're not going to test you on that. Don't worry about it. You just got to make sure you understand how the hardware, zeros and ones, how it gets to your screen to text. That's all you need to understand. Questions, doubts? All right, next area. So we're going to learn now basic process of the computer itself. I need to understand this because this sucker is important. Key thing we're going to notice here is some words that are going on. So here we are. We got the data. He comes in through the input device. So I'm here and I'm typing. That little motion throws all those winds and onto the motherboard, which gets sent to the CPU by the memory itself. Motherboard is always the guy we ride. We ride the bus. Everything gets intertwined through the motherboard itself. When it gets to there, then the CPU processes the actual data based on the input in and the program that is installed in the memory. The memory there has, okay, this is Excel, this is the type of language I'm using, here's the zeros and ones that got to do with this. All of that comes back and forth to each other. And eventually, when the CPU is finished, of processes the data, it then represents it through an actual output device, me moving the thing, got all the memory going through here. You'll see that now all of a sudden it highlights. All that requires resources being refreshed at all times, going at lightning speed, only electricity, by the way, through the actual motherboard representing ones and zeros. And finally, the information can be either stored to the computer memory and or the hard drives at the end. So it will flow in that direction. Questions or doubts on the computer stages of a basic understanding of the process? So how would growth mindset help us to keep in with the changes in the way computers are made? How can growth mindset help me? Anyone? What would growth
Well,
mindset help me out
computers are
with?
always changing, so you know they always get updated with better processors, better memory.
Hmm. That's correct. As long as we understand the basic concept here and we understand that we should just learn the new stuff, we should be up to date with the latest trends and or devices. Obviously, uh, the key aspects of it is not going to change. Everything that I learned in 1987 still holds true today, except for the math processor, which I believe was created right after that. But it still holds true today. The only variance, like I said, now we have plug and pray or plug and play versus manually doing stuff. So number one, my CPU is able to take my data from the input and then output it for me. What is this process called? Is this an input output translation, IPO, or processing?
Say it out loud or just click it on the.
Click it on it, yeah. And if you wish to respond, whichever way. Processing. I got one vote for processing. Anyone else like to agree, disagree? Next question. I think we would have to agree with processing for now. I don't have anybody else voting no.
I put
True or
A,
false?
honest. I put A. I'm sorry. I put A, but I think that's probably wrong now. I think about it, but I'm gonna stick with A.
Okay. So we had one vote for A, one vote for C. Number two, a microphone is considered an output device. Is that true or false? A microphone. From what we learned.
No, that's
False.
False. I got several
False.
votes for false, one vote for true. All right, we'll go with false. You seems to be unanimously pushing that way. True or false? A DVD drive can be, sorry, a DVD RW can do input and output. DVD RW. Anybody
True.
remember what a DVD is? Anyone know what a DVD is?
Like the 8 tracks back in the 70s.
Redbox is pretty hot, so hopefully.
Isn't
Pretty sure you DVDs is the round guy, the CDs.
It's a
But the
movie thing.
DVDs is the
Blockbuster
movie
used to
one.
have them.
And That's the drive
Wow.
that you can also write on DVDs, right?
In this case, you are correct. The key letters there was read write, RW. Therefore, this specific model of DVD is input and output. It was a trick question for those that didn't recognize that RW meant read and write. Because a DVD R could only read, then that, my friend, would be input only. But the point that here it has the RW, this specific device does both jobs. It can be an input and it can be an output itself if you're saving files to it. Kind of answered the next one. DVD-ROM, can that be an input and output?
No.
Right.
Okay. Mm, let's share. Let's see what we got. Woohoo! We got 100%, guys. So we said number one was processing, which is correct. The actual input and output through the CPU is the processing part. We've stated that the output is false for a microphone because it is an input device, and the variance between the actual two drives themselves. Next here, we have inputs. As you'll notice, we covered here various ones. We have our keyboard, we have our mouse, we have our drives, we have our scanner, digital camera, modem, microphone, and NICs. From what we see here and what we just might have got a hint on from this list, can anybody tell me which one is an input and can be an output that is on this screen at this moment? I'm sorry, whoever's speaking sounds like a robot inside water.
The
Drives.
NIC, the NIC.
Drives, the NIC, network interface card. Okay. Anything else? Modem. Okay. Anything else?
Voting for modem also.
I'm sorry?
Modem,
Yes,
I
modem
think.
is, modem is also a input and an output.
How about the
Anything else
drive?
here? Yes, I believe somebody mentioned a hard drive. You can input and output information from it. Anything else?
There are
Depending on
specialized
the scanner
work.
itself, depending on your scanner itself, here, this could be an input and an output. Some scanners do have capabilities of being able to receive printing jobs and stuff like that. So that would be a tricky one, depending. Also, it could have some of these scanners have a screen, believe it or not, on them. So that part of the scanner itself would be considered an output. Your digital camera itself can be an input and an output the moment that you are downloading pictures to the PC or uploading from the PC back to the camera to its memory card. Processing. Here we are, the CPU, your RAM, and your drives and your motherboard. As for the processing itself, we need to take note. Your CPU is the guy that does all of the work. So how does this work? Well, the motherboard is the guy who he talks to. Everything goes through the motherboard. He is the bus. He is what everybody is writing. You see those little gold or nowadays I don't even think it's gold. I think they're using copper, but that little super highway that you can see there next to it, everything rides the bus. The green ugly foam in the background is the actual motherboard itself. I wish this thing would stop. Does anybody turn off? Thank you, Lord Jesus Christ. Now I got me all sidetracked like little puppy dog. So anyway, so our CPU talks to the motherboard talks to the RAM goes to the drives. Everybody goes through the motherboard. If these three components need to talk, it must pass through the motherboard. So if I want to receive a file, I retrieve it from here, gets to the motherboard, gets sent to the RAM sends it to the CPU. They keep on talking to each other. It goes like this vicious cycle of processing. vicious cycle processing also here, and the dangers is if you start doing what I'm doing. I have a plethora of stuff open in the background. Fair warning, your RAM utilizes everything that's in here. So the moment that you have too much open, too many programs open, your computer will most likely either become very slow or have a very high chance of basically giving you a blue screen of death or crashing itself. Therefore, depending on the actual computer itself and the amount of memory and CPU processing power, you should take note of that, and that should help you out. So whenever you walk into an actual user who gives you an ID10T error, please take note. It may be that the problem is that they have a plethora of stuff open and they expect it to continue running. Can anybody, except for any of the TAs, answer to me what an ID10T error is? I'll give you a hint. Spell it out with a piece of paper. Nobody? No? Come on. User error. The user error is vicious, so we need to be able to decipher, is it a user error or is it an actual error of the system itself?
Is that a
Just
real
a little
thing?
game.
Is that a real thing?
Yes.
We
Like,
don't use it and explain it to a user, but we will give them the actual error code.
The other one is a picnic error.
Mm-hmm.
Problem in chair, not in keyboard or
Yeah,
computer.
yeah.
Haha.
Those are the ways we are able to communicate with each other without the user actually noticing. Some users may know those key terms, so I won't use that too much, but just so you know that that does exist, we do play around with our little codes. But fair warning, you'll even learn we are that part of troubleshooting does exist. Not the ID10T error, but just the actual user error itself per se. And ID10T does not exist for A+, so don't need to memorize that. Outputs, as we said earlier, that's speakers, printers, monitors, NICs, drives, and modems. If you notice, as we said a little while ago, there goes the NIC, there goes our drives, there goes our modem. Here comes the printer part, which I said earlier could have been an all-in-one if it has a scanner. But if we get the point, it goes out from the computer versus the other one goes into the computer. Now, my friends, we are how a computer works. I believe we have a form available for you guys to play with. We'll be dropping that into the be very careful when we're dealing with this. And the reason we want to learn about these terminologies is because of the fact that the capacitor holds this electricity is one of the reasons why we're asked to actually unplug the device and attempt to turn it on. I know it sounds silly that they're asking you to turn it on because it's unplugged, but now we know why. Because the capacitor holds electricity and it's waiting for that button to be pressed. The moment that that button is pressed, it releases and says, hey, I want to get turned on, it looks like. Let's go, turn this thing on. The moment you do that, and since it is not plugged in, it releases all of its charge from the capacitors, and now it's safe to be able to open the actual case. Failure to do this and release it will create problems and you will damage your computer. Questions on any of these little words or intricacies of the words we just learned?
Yes. What was the equation for watt again?
Volts times ampage, VA. Most thing that you need to understand what a volt is, which is just a unit of electricity, which is a force. The other one is the actual consumption or the amount of pressure. Reason you need to know watts, especially when you're dealing with computers, is when you're going to purchase a PSU, power supply unit, or a UPS, an uninterrupted power supply in server rooms or in your house. You need to understand how much wattage is your computer consuming to then do the calculation based on that. Usually these devices have a way of saying, okay, you got so many watts, that's how many minutes I'm going to stay on. Based on the amount of watts that you're using, That's how many minutes I can stay without having electricity.
I have a question.
Hmm.
So a capacitor holds electricity, but what's the difference between that and like a battery? Because that also stores electricity.
Good question. If I press the button on a laptop and I have the battery on, it turns on and it is a long-term storage device that slowly, like you could always think it as those new capsules. A capacitor will be one of those quick release, while you have the other capsules which are long-term release, and throughout the whole day the medicine comes to you. So that's what that battery is. It's long-term. It's going to release the energy at a slow rate. A capacitor only holds a small bit of energy in there. Doesn't have that long term of, if your remote control can probably last about months with that battery, right? Or if it's your phone, it lasts hours without the battery. But the moment that we take out the battery from the actual phone and we attempt to turn on the phone, the capacitor releases its charge. Everything's gone. Make sense?
Yes, thank you.
Not a problem. Protecting yourself. Okay. So we are. Let's go with Elizabeth. If you can read, please. Protecting yourself.
Sure. Okay. Protecting yourself from shock. Always disconnect power sources before working inside a computer, discharging residual power stored in the motherboard. Do not ground yourself because power could flow through you to the ground and you may get shocked.
Thank you. And another key thing that we want to learn is obviously that power supplies, printers, CRTs, as I mentioned earlier, contain capacitors and are rated as an electrician repairs only. We are not to touch this. If you receive a job that's asking you to take apart a monitor, especially catheter radion tube monitor, that's the old tube monitors. I don't know about you, but I would probably be quitting because that is very dangerous. You got to be an electrician to understand that that tube has a lot of stored energy beyond the 110 volts. That tube inside has a lot of energy. Therefore, printers inside we don't touch. We will troubleshoot paper jam, toner, fuser assembly, which we'll learn all these key things that we can touch. But there is parts that are not plug and pray. No es un quita y pon, like they like to say here, the Cubans. It's not just to take out and put in. Just don't release the screws, put the screws in, and you're in. Anything that we do not cover here, you do not touch. No reason why. There's special people that do that. Any questions or concern in reference to protecting yourself? Now, quick key thing of this residual power and how to release. Not only are we releasing it on the actual device, we need to make sure we release it on ourselves. All right, we need to be careful because of the fact that we have actual electricity on ourselves. We need to make sure that we ground ourselves. And one easy way is touching the screw that is in the back of the computer. There is 4 screws that are attached to the big humongous fan where the power unit is. What this does, it technically doesn't ground you, but it does put you to the equivalent static energy that the computer has. You do release your energy to it and it to you at the same time. What do I mean by that? I'm pretty sure it happens to you. You went and gave a handshake to your friend and all of a sudden you went, you're like, what? You shocked me. Exactly what I'm talking about. The problem was that you had the static cling that was much higher than him or her. Therefore, since that variance of voltage exists, the person with less residual charge receives the actual zap, and the guy that has the higher one usually just hears it or feels a little tingle of it getting released. This is what happens to your actual chips if you do that. Fair warning, Do not touch anything unless if you have completely grounded yourself correctly. Now, safety rules in reference to the extinguished fires. Never, never, ever, 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 ever use water to turn off an electric fire. We need to learn that A, yes, that is the usual one that'll put off wood and any other combustible regular papers. B refers to liquids themselves. You could always think of it if A is the physical hard stuff, B is my liquid stuff. I don't think you could use it on mercury. I'm not trying to make a bad joke, but that's besides the point. And C is your actual one that you will be using a lot here. No, hopefully not, because if you are using it, then there's a fire, but you get my point. C class is the one that is a non-conductive chemical to put out fires. There is other ones, which is called halons and other things that we're going to learn in reference to. Halon will suck all the air out of the room, and basically you better run if you hear that halon go off, because unless if you want to get knocked out, it will take out all oxygen. Next, ESD. So here we are. Yusuf, help us out here with the ESD portion here, the first part.
Just read the first part.
Yes, and the two bullets with it. Yeah.
Electric static discharge, ESD. Electric charge at rest. When the two objects with dissimilar electric charges touch, electricity passes between them until the charges are equal. Can be felt at 2,000 and 3,000 volts as a slight zap, but components are vulnerable at 100 volts.
Thank you. So as we see there, we humans feel it at 2 to 3,000 volts. Let you pause and think about that. We're able to, when you go, feel it at 2 to 3,000 volts, and it feels like a tingle to me and you. Some people like to cry and exaggerate, but you get my point. What's the problem you see here right after you? What is the threshold of a computer component, Fadil? What's the major problem with that sentence? I can feel it at 2 to 3. But what's wrong with the computer? Where does he feel it? Where does he get hurt?
Which damage the CPU?
Yeah, it'll damage the CPU, but at what rate? At what is the maximum voltage before a component gets damaged?
100 volt?
100 volts. Correct. 100 volts. Therefore, we are more than 20 times that.
Wow.
Is it honing into you guys how vulnerable these things are?
Yes, because it only takes a little bit, and we think that the static that we feel is nothing, but it's actually a lot more than the computer can
Yeah.
take.
And that's the reason why we must protect ourselves, ensure that we ground ourselves correctly. We're going to also see uh, key devices that are going to be able to help us with this. But the key thing is to understand that although for us it seems to be nothing, 2 to 3,000 volts, I didn't know that until I got into computers that it was actually that many volts. Just think about it. They're telling me that the electricity in the wall is at 110 volts. I do understand there is amperage and it's coming out at watts, right? Because that's the pressure. Boom. If you remember, in your little thing there, when you go to your panel at your house, you could see the amount of amps. That's the circuit breaker. That's the amount of amps before the circuit will break, and it won't allow you to pull more than what that circuit breaker says. Does that make sense? Anybody know what I'm talking about? Circuit breaker in your house. So you go to the little circuit breaker, it says 20, it says 60 amps. That means that that's the amount that the wire can hold before it will be considered too much. 110 plus all those amps together, too much flowing through here. And that's what's dangerous about electricity in these computers. So it's catastrophic. It will destroy a component. It's going to damage the component. Sometimes it even damages to the point that you do not notice, and it is the most annoying thing in the world because you cannot diagnose it anywhere, and it's sporadically your computer just keeps on crashing. Because unfortunately somebody didn't ground themselves correctly. They messed up one small little capacitor in there, and every time it gets to that capacitor, dead in the water. Questions?
Would that be
Doubts?
unfixable? Would that be unfixable then?
Well, it is technically back in the days, you had to learn also soldering because it would happen a lot to the old keyboard, the old, not the PS2, but the old keyboard. It actually had a fuse on it. Uh, but nowadays, the cost would be too tremendous for me to have somebody to go purchase that little capacitor, unsolder it, solder it back. For that, I just go buy the board. The cost associated of labor to the actual component and having a supercomputer assemble a motherboard is much cheaper than me having somebody take apart the motherboard to figure out where he's going to have to go with a ohm reader and or a special electrical tool reader to figure out where the break is. Too many hours of work. Make sense? They used to do it. Some people are cheap enough or some people are willing to fix it. Most people nowadays won't do that. They'll just replace the motherboard or the board that's giving the problem. Any questions or doubts?
Is there any other measures you'll take other than grounding to?
Yes, we're going to get to those. Good question, and where we're getting and alluding to the safety equipment itself to prevent the actual ESD, the electric static discharge. You have your ESD bracelet with this guy here that you see on the screen right now. You have your ESD mats. Your bracelet itself allows you to connect. As you see, this is your wrist. Here's the little cable that connects and snaps on. This can go to the back of the computer, to the chassis, and or there's ESD mats, which allow you to actually clip yourself to them, which will also do the exact same thing. It allows you to release any ESD that you have. There's also things that called anti-static bags. These little anti-static bags themselves are very useful. The little bag here, it itself, you could put the component in here. No longer do I have to go and touch your shoulder or do anything to release. I put it inside the bag, I give you the bag, and there is no static charge in this bag. It's called the miracle bag. I'm not just kidding. It is an ESD bag. It's not. I don't know how it works, but it doesn't allow any electricity to flow through it. Just go with it. They gave it to you. Use it. They all come in there. So if I buy a brand new memory chip, if I buy a brand new motherboard, if I buy anything that's a computer part, it is stored in one of these type of bags. It may look like this. It may be transparent. Whatever it is, if it came in the bag, that's the anti-static bag that deals with that component. Now I take out the old one, put it in, out of the computer, put it inside the bag. Sorry, take out the new one, right? And then put the old one in the bag, vice versa, whatever, and put it away. Because if the damage, if it is just an upgraded component and it's not damaged, I don't want to damage it myself. So I put it in the bag. As for ESD gloves, those are cute also, and those are basically gloves, and their ESD gloves themselves are what they are. It's just the gloves that you wear, and they're anti-static gloves. They're meant to, instead of you putting on an actual bracelet, you wear that, and just like your rubber sneakers and or special sneakers there is around there for you to be walking, it will avoid you from electrocuting the components. Questions, doubts
You
on
have to
these four?
do you have to like wear those gloves if you take out the component from the bag after you purchase it and then
The gloves are to replace the bracelet and the mat. In other words,
okay.
you won't need a bracelet and you won't need the mat to ground yourself. The gloves themselves would avoid you transferring. Now, what happens though if you put the component on top of a metal desk or your workbench? instead of the ESD mat, it it will damage it. Be careful because a lot of your benches are metal benches. Therefore, they require that special mat because the bench itself usually is grounded, believe it or not. So therefore, the gloves is for you to avoid you giving the component damage. The bags is for storage to avoid it touching anything else. And the bracelet and the mats are for you to avoid problems with the components. Okay, protection rules. Protection rules. Let's go with Kevin. Help me out, dear. Number 1.
When working with someone else, touch the other person before you pass components between you.
2, Michael.
Sorry, you store components inside anti-static bags until ready to install them.
Thank you. Ayana, Bando, please, number 3.
Always try to work on hard floors, not carpet, or use an anti-static mat.
Thank you. 4, Than.
When working on computer, check humidity to be sure it is not dry, which will steady electricity.
Yeah, interesting how we need to even check humidity, huh? 5, Muhaba. Muhaba Bashir. Thank you.
Yes.
Number 5, if you can read it for us. Thank you.
Remove packing tape and in another room, as these materials attract ASD.
Yeah, that one I haven't mentioned yet, but I'm pretty sure you guys have played around with that. Anybody ever mess with their hair and go like that with the packing material and then your hair goes up? Well, that's the guy right there. All those packing material. Be careful with the bubble wrap and all that extra stuff. That's got plenty of static energy can't see. Next, number 6, Anne, if you can help us out.
Tie back long hair and remove loose jewelry and clothing when handling components and reaching inside the computer.
Yeah, that's another one that I haven't mentioned yet. Anybody have want to give us a clue on why I should tie my hair back? Specifically, the one that I always get worried is with Kelly when he doesn't tie his hair back because he's dangerous. His hair is just too long.
It's been an ongoing struggle.
I know. Anyone want to take
Is
a
it
quick
because
guess?
when your
I'm
is
sorry,
it
Nicole. Go ahead.
because when your hair brushes against you, it creates a static charge?
Yeah, your hair does have electrical charge. That's correct. That's one thing. Could you imagine though if your hair got stuck on one of those fans? Ouch, right? Hopefully you turned it off to begin with, so it's not going to be a major problem, but it could get, if you're reaching in and the fan is there and it gets stuck on that little fan, that's another thing. So why should I take off also loose jewelry? So we know why hair, so hair may get stuck somewhere, that's one, or it may create an electric static as we learned, because my hair, if I put a balloon next to it, has that static cling, right?
It's metallic, right?
Bing,
So
bing, closing of a bridge. Exactly what's the problem there. It's a metal bridge. Therefore, this ring right here, the moment it touches the motherboard, will obviously connect and bridge those two sides of the motherboard. As I stated earlier, the motherboard itself runs on 12, 5, and 3 volts. Therefore, if you bridge a 3 with a 12, you could only understand that the 12 will be catastrophic on the 3. Any component that's supposed to run on 3 volts, you throw 4 times that onto it, it's gone. Questions or doubts on why these 6 are critical? All right. Go a little bit here. We're going into the essential tools, demagnetize in a toolbox. You want your grounding bracelet, as you see here. This is the usual little kit that usually people have on when they first start. You can buy this anywhere that like Amazon and different locations, and it comes with its own little grounding bracelet, grounding little mat sometimes. Even anti-static gloves are possible depending on the type of little kit that you buy. You get a chip extractor, and it has various different tools in here, including your little Allen wrenches, the little box so you can store your little screws, or even have spare screws, because all PCs, computers only, hasta ahí, no more, no más, have the exact same screw and strip. After that, good luck. A scanner, a phone, a laptop, you name it, has a different type of screw and thread. What is a computer, a PC? Didn't say Apple, a PC. That, my friend, you're going to have that little bucket with extra screws for that. Those are all the exact same size and thread. Besides on the motherboard, because sometimes the motherboard has a different screws, but the normal screws that are on the case, the normal screws that are on the expansion slots are usually the same size. Questions or doubts on the little kit?
Question, is there any magnet in the computer?
We keep magnets away. And yes, there is magnets in the computer, but we keep magnets away from it. Reason why is that since everything is magnetized in there, which becomes with data, the moment that we introduce our own magnet into this, we'll damage the components and lose information. So if you ever wanted to erase your hard drive, just get yourself an industrial magnet, pass it right in front of the hard drive, and that should do it. That'll damage it for sure. So our screwdrivers must be demagnetized. I know a lot of people love it because nowadays there's screwdrivers where you have the little magnet on it and it makes it easy to do mechanic work and stuff. Not inside a computer, my friends. There is some special screwdrivers that have a small little magnet and tell you that they are for a computer. I wouldn't recommend it, but there is some of them that have a low enough magnetism that it won't damage it as long as you don't touch the motherboard directly with it, but I wouldn't do it.
Typically, we use a screw extractor. Looks kind of like this. Let's see if I can get it up here. See the little teeth coming in and out? Instead of a magnet, you would use something like that to pull your screws out.
That is the easiest way, correct. He takes out his teeth and he grabs the screw and he allows you to take it out. Looks like 3 little hairs at the end of the tool tip. Any questions, doubts? All right, guys, we ran into 2 o'clock. We'll continue with this when we come back at the afternoon session. I will pause everything here and I'll see you guys at 3 p.m. And if you can please pause the recording for now until we get back.
Take care.
Have a good lunch, guys. See you in an hour.
Yeah.
I would have put a cute song, but somehow for me, YouTube is stuck. No lie. I have no idea why. I go to YouTube, watch it make a liar of me. Anything. And when I hit play, it doesn't do the ad. It just clocks away. Interesting to say the least. I don't think it likes me. And it's not the browser. I already tried several browsers. So I wasn't going to restart my PC, which is the only other choice to do at this point. Or log off and log back on again. Got 2 minutes, 2 minutes. Anti-static gloves, the chip extractor, which we can see here, this guy right here, that's a chip extractor, and the screws. And it's 3 o'clock. Here we go. Reference to the tools that are necessary overall. We have the post diagnostic cards. As I stated earlier, post, which is actually means power on self-test, basically the computer itself or the actual firmware that you have on the motherboard is able to do a post. Sometimes there is problems with the actual BIOS or the actual computer that cannot be self-diagnosed, diagnosed. There we go. So you have your little PCI version here of a postcard, and you have a USB version. It does the exact same thing. The variance is that if there is a problem with your motherboard itself and or the firmware, this little puppy will obviously be able to detect the error and give you a number that corresponds to the error. That's what you see here, that little digital screen. With this, you go to the websites most likely, or it comes usually with a book, at least back in the days when I used to play with that guy. I'm pretty sure right now it is a digital book. And with that code, you're able to determine exactly what is the problem with the motherboard, be that it is maybe the memory or VGA card, even a loose power cable. This sucker here can tell you that at least he can't see the floppy drive. Oops, I don't think that exists anymore. But anyways, a DVD drive. Boy, am I getting old. Questions or concerns on a post card and its job. Hello, 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 hello. Is anybody out there? Out there? Out there?
Did we just start or did we start?
And I'm
I know
first.
I know I'm 2 minutes late.
I can't hear anybody. Can anybody hear me?
We can hear you.
I can hear you.
Hello.
I can hear
No questions
you.
at the moment.
Can you hear me now?
Yeah.
Yes, no, maybe so.
Yes, we heard you through the whole
Yes.
thing.
Nope.
I was asking, did we
Might
just
not.
start? Because it seems like we're in the middle of
Let
something.
me see in the chats. Okay, you can hear me. All right, so we'll work with that. I'll put the little chat box over here for now, and then hopefully won't get in my way. To modern technology. Give me a second. Okay, try this one more time. Sorry about that. Can somebody respond? If not, we'll just
Hear you.
work with this.
I can hear you.
We hear you.
We'll work with this. Sorry about that, guys. All right. That's what we get. Gotta love it. All right, we'll continue here then with what we got, unfortunately. In reference to this, then I guess I can try to keep the screen on this side. For the postcards, was there any questions or doubts? You can shake a yes or no, and I guess we can work with that. No? No questions, doubts. Alrighty then. So we'll continue with the next slide. As for the tools that are necessary and the equipment, you do have a crimper. The crimping tool is this guy that you see here with the different sizes. One's RJ45, the other one's RJ11. RJ11 is for your actual phone cords. and your RJ45 are for your Ethernet cables. We will see the details of those variances in later chapters, but we just want to be able to identify a crimper. We must be able to identify our punch down tools, our toners, and we have over here an actual multimeter, which has the ohm reader and various other things to give us electricity and circuits and stuff like that we would like to test. Overall, your crimper does that. It crimps your actual cables. It can be for a bank connector, but in this case, this one that we see is actually for a Ethernet cable or a Cat6 cable that you're trying to crimp. You have your cable strippers themselves. This unit has a cable stripper integrated within it, but there is a dedicated cable stripper just to be able to peel the cables. As I said a moment ago, your multimeter here is a device that you use to be able to see circuits themselves and or voltage. It has different variances. I'm not sure if you've ever been to class of electricity, but that little sucker does different types of things there. As for the actual tone generator, you have over here the actual, no, that's not it. That's not even close to being one. Here we are. That's a tone generator there. A tone generator device itself, as you see, you have the guy that screams and he goes, "Leelu, leelu, 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 leelu." Yes, it does that, believe it or not. I'm not trying to be funny. This sucker goes on the side that you're going to plug it in where you have no idea when it goes across to the other side of the facility to what we call an MDF, which is a main distribution frame or closet where the main servers are, or it can go to an IDF, which is an intermediate distribution frame, which means just a fancy of a remote closet. Either which way, some people don't label things correctly, and unfortunately then, or the label falls off or you can't see what that number corresponds. This guy here is able to then generate that actual noise through the actual cable. The second one here that has the actual little speaker attached to it can actually listen on the other side. Both together must work. If not, you won't be able to do anything. Just a side note, as you see, it has two extra little things. You have the actual thing that plugs in. If it's not connected to an Ethernet port, in other words, not connected to a switch on the other side, it will tone perfectly. Unfortunately, for some weird reason, I could never figure it out. I take it because of the send and receive is the only thing that makes sense. If it is connected to the switch somehow swallows the noise, don't ask me how, and it's disappears. The tone just completely disappears. So the only thing you can do is create your own little cable, you splice it, and then just grab onto two pairs that are not corresponding to their colors. There's blue, there's orange, there's green, and there's brown. Just as long as you don't pick the same pair, which one responds for sending, the other one for receiving, you see that there's white, brown, and brown. As long as you pick one brown and one orange, you're fine and dandy. Just by holding on to those two, it will generate the sound and it will not eat it on the other end. Just a little trick of trait. So whenever that happens to you, a lot of people don't know that little trick. Any questions on what a toner is and its function? Go back to the video. I would have to chat it if I were you guys.
Another thing they would call it, possibly in the test, is called fox and hound. It's another name for the same thing.
Next. A cable stripper is basically that, as you guys note. I'm pretty sure you've seen a cable stripper before. That's not complicated. As for a loopback plug, is that in itself, it's actually a plug. When you plug it in, it actually loops back the signal. This is so that you don't have to have a cable or create a cable that comes back. You could actually just put that to the port and it will send back the signal, therefore confirming if everything's okay. As for this guy over here, which is one of the ones that you will be using a lot, is a cable tester. The cable tester is able to facilitate you testing out an actual cable. It'll light up every single light corresponding to every strand that's on each side. You could either have the cable here and just plug on the two ports themselves, and or you could connect to one port on this side, and then on the other side, you connect this little thing actually separates and you put it on the other side of the closet, you connect it, and you can see if the drop is good. Obviously, it should go 1 through 8 continuously on the other side. This is the sending unit. This would be the receiving unit. So when you're on the other side, you can make sure that all these lights light up one at a time. questions, doubts on toner, just drop it into the chat. I have that extra window now open. No questions or doubts on any of the tools. Wi-Fi analyzer, as it says, it analyzes the actual Wi-Fi. Thank you. This is going to be challenging. Learn to adapt, Diego. Learn to adapt. Woohoo! Kahoot. Believe now we have an activity for you guys within Kahoot. And I pass it off to a TA at this point to instruct you on the activity and the pin. Is that you, Lázaro, or Kelly, that has the Kahoot activity for this?
I got it up.
A shake of the head, a yes or a no would be sufficient if, oh, okay, there we go. There goes the Kahoot number. That's the number? Okay.
Oh, I thought it was a cat.
All right.
I'm in.
Thank you, Justin. So the code was 1, 2, 3. No, I'm just kidding. 1, 2, 1, 3, 4, 9, 6.
All right. Is everyone in?
I'm not in.
All right, one moment. We'll hold on. All righty. Okay. The answer would be low humidity. Grounding strap is the metal strap that goes, or strap that goes around your wrist and attaches to the computer. It allows the charge to be dissipated through the wire rather than jumping from you to the components. You would remove loose jewelry because you can jump the connection between points. Low humidity would not be an indicator, as any, especially if you live up north, when you have your heaters running in the wintertime and, it drops the humidity significantly in the house, you seem to shock yourself on the doorknob every single time you go. So that would be the one thing that would not.
I got confused from high humidity. That's why.
Well, why would high humidity be a bad thing?
I know, but high humidity would prevent the static charge. So I mistook the low versus high, and so I didn't answer the low humidity.
But why would high humidity be a big problem for computer components?
Well, maybe it would cause water droplets or something. I don't know.
Condensation, and also could cause rusting.
I can hear. Yes.
Yay! There you go. All right.
It's like in an airplane. Cool. Sorry. Go ahead. Continue.
All right. Looks like we got Yusuf in the lead. ESD is the correct answer, electrostatic discharge. Got a couple for DSL. ESP doesn't really have to do with computers, it's extrasensory perception. And EMI is electromagnetic interference. That's something we will learn about a little later. And DSL is a type of internet transmission. All right, did Ayana move up? Excellent. Excellent. Arturo moving up the board. Very good. First thing you always want to do whenever you're messing with any hardware components, or you're messing with any electronics, if you're going to physically be manipulating components, you want to make sure you disconnect the power source and dissipate any residual charge. Typically do this by holding the power button for at least 5 seconds after the computer has been turned off and unplugged. And last question. Very good, very good. Also, you know, that it seems silly, but that is one to definitely keep in mind, because you will see questions continually rise up about fire extinguisher classes. So that's a good one to just kind of keep in the back of your mind. All righty.
Thank you very much. Oh. Who did win? Who won? Who won? Who won? You were supposed to show us. We can't see that. Can we see it? All I see is tricky game. Best yet.
Congrats, Yusuf.
Yusuf. Oh, now I see it. Maybe if I move this out of the way, Diego. Thank you, Diego. Cool. You guys had fun there? Got your brain cells working on that? All right,
Yes, it was fun.
cool. Next area here. Hopefully we're now able to describe. Wait a minute, maybe if I do this again instead of just blabbing. Do apologize. Hopefully by now we should be able to describe how computers work, including the relationship between the actual hardware and software, explain the key safety precautions to take and tools to use to protect yourself and the computer. So who can tell me maybe some tools they are available to avoid any ESD charges? Give me an
Special
example.
gloves. Special gloves.
The ESD gloves, okay.
ESD bracelet.
ESD bracelet.
Okay.
The
Okay.
ground mat.
Yeah, the
Mat.
ESD mat. Yeah,
The
definitely.
anti-static bags.
That's another one, right? That one helps out. Cool. Can we now determine the variance between an input and output of hardware? What is considered your processing? We know that now, how it works, the whole steps of what is in that
Yeah.
processing area. Those are the ones that are tricky because they are technically pieces of hardware that's in there, right? So what's the
CPU. CPU.
Hard drive.
Motherboard. Drive.
mm-hmm,
RAM.
and
RAM.
RAM, right? Then we learned that there is a ROM chip that you can always think about it as a little mini program. I guess that's the only thing I can try to rephrase it as being, where it has a plethora of dictionaries. And with these little dictionaries, it's able to tell if this is a hard drive, how can I talk to it? If this is a video card, how do I talk to it? By its manufacturer and everything, has everything. It will recognize, you'll see it says Seagate when it says hard drive, and it'll tell you how big it is and everything. That what the actual
Can't hear you.
Lost sound, Diego.
can you hear me now?
Yes, sir.
Yes.
Yes, we can.
You gotta love modern technology. I tell you, it's just gonna test me today. As long as we can adapt and communicate, I think we may get through this yet. All right. Can you guys still hear me?
Yes.
Awesome. And I can still hear you. Any other questions or concerns on this one?
Nope.
Nope.
All right. We were supposed to go from here to our break, but inside your Canvas, feel free after class. We'll be reviewing any of the stuff that's inside Canvas itself and review your quiz. But time permitting, we've gone a little bit too behind. So I will be stopping this session here. It is in your Canvas. Okay, guys? Next session we will be covering is growth mindset. And the link for this puppy is oh, never mind. I think